Hey there, it's Jillian, and we are going to take a look at completing the square today. Hang on, let's get focused. There we go. So we know sometimes we are given information in standard form, and we see how useful it is to have things in vertex form. So we need to learn how to convert a standard form equation into vertex form, and that method is called completing the square. So we make this a perfect square. So some of the reasons why we prefer to have a quadratic equation in vertex form is so that we can see the vertex, right? We can see the stretch. We know whether it's in this form or this form. We can see the Actually, we can see the stretch in both places, and also we can see the direction of opening. But we can see the shift, right, left, up, down, and we can see the vertex. And so those are some of the reasons why we prefer to have a quadratic equation in the vertex form. All right, so let's find the value of c that's going to make each expression a perfect square. Okay, so a perfect square means that when we factor it, the two factors will be the same. So if that's x, the signs are the same, they're both negative. So what number would this be if we wanted to have these be the same number? Well, if these are going to be the same number and they're going to add to this, they have to be both -6, right? Because -6 times a -6 give us -12. And if that's the case, then c is 6 times 6, which is 36. All right, so let's do that for this one now. Here we want, and then of course this could be written as a perfect square, because anything times itself is that. So here, let's do this again. X signs are the same, they're both positive. And what could that be? Well, what are the two numbers? That is some number plus itself that gives us 18. Well, of course, it's 9 and 9. And 9 plus 9 is 18, and 9 times 9 is 81. So this would be a 9. So what I hope you're noticing is you could just like take this number, cut it in half, and then square it, and then you get the number for C. So let's see if that works. Take this number, cut it in half is 10. And square it, and that'll be 100. And of course, you can FOIL out any of these brackets to see if you get it. So for example, x times x is x squared. X times 10 and x times 10, 10x and 10x are 20x. And then 10 times 10 is 100. Oh, that's how we do it. So now let's take a look at the steps. I'm going to walk you through the steps one by one. So when we have this and we want to put it in quadratic form, here's what we do. First, we determine what will make this a perfect square trinomial. So we do exactly what we just did. We take it and cut it in half and then square it. So half of that is 3, and 3 squared is 9. So 9 is going to be the answer. And then what we do is we take that 9 and we add and subtract it. Because you see, when you have this, and you want to write the next line, you want to add a 9 there. You have to also subtract 9, because then what you have here is exactly the same as this, because you've basically added nothing. 9 minus 9 is 0. So whenever you add something, you have to subtract it as well. You'll see when I do the full example a little bit better. Then these three are the perfect square trinomial, so we know that half of this is 3, so it's going to be x, whatever that sign is, 3. And then you continue on. So let's try an example. I think it's going to be much easier when we try an example. Okay, So I'm not going to look at these steps anymore. I'm just going to do this question. So y equals x squared minus 4x plus 2. So half of that squared, half is 2, 2 squared is 4. So I'm going to rewrite this. I'm going to add 4, subtract 4, so it's still equal. Wait, what am I doing? So when I add 0, which is 4 minus 4, these lines are still equal. And then I'm going to take these first 3 and make it a perfect square, that sign, half of that. And then I still have this and this, which I'm now going to collect to -2. And now I have this equation in vertex form. That's it. Now, in this example, you're going to see there's a 2 in front of the x squared, as opposed to not having a 2 in front of the x squared. So when the a in front of the x squared is 1, this is the process. When there's a 2 here, there's one step we do in advance, and then we do the rest of this. So let's see here. Y equals 2x squared plus 4x plus 5. So the step that we do is we need to have x squared on its own, and we don't have it. We have a 2 here. So we're going to common factor out of all the terms that have a variable, list when we leave, but out of all the terms that have a variable, we're going to common factor out whatever is in front of the x squared. So it's bracket x squared. And then we're going to do what we did here. Half of this is 1. 1 squared is 1. So we'll add and subtract 1. So it's like adding 0. It's still the same. Then these 3, x, that sign, half of that. And then we have this, right? Still in the brackets multiplied by 2 plus that. So now what we need to do is we want to collect this with this the way we did up here. But the problem is that this is in that bracket with the 2. So what we're going to do is we're going to leave this like this, and we're going to do -1 times 2 to get it out of the bracket. And then once we do, we can collect them. And that's what we do. Okay, let's try another one. There we go. So y equals 3x squared minus 18x plus 1. First step is to common factor out whatever's in front of the x squared out of only the terms that have a variable. Then we're going to do our half and square thing. So half of 6 is 3, 3 squared is 9, add and subtract it. Then we're going to take these 3, that sign, half of that, and then this is still in here, plus 1. -9 times 3 is -27. Now it's out of the brackets and we can collect it with the plus 1. Ta-da!